gonna see why I have to find this h and why I have to find h plus 1.5 later on in part C. So now I know the velocity of v in x and y just before collision. The collision occurs with the wall, which means here I know that the wall has a mass of infinity. In central impact, I know that if I have a wall, I only have to apply the equation of coefficient of restitution. Now, what about the oblique impact? In fact, in oblique impact, so let's write it down. In oblique impact, if I have wall, floor, ceiling, or anything in infinity of mass, compared, of course, to other masses, the four equations will be only two. First one will be the linear momentum conservation of the mass and not of the wall in the perpendicular line, the line of impact, of course, and the second one, in the second equation, will be the coefficient of restitution along the line of impact. Alright, guys? So if I have a wall in oblique impact, the two useful equations are the coefficient of restitution along the line of impact, like we did for the central impact, plus the linear momentum conservation of the mass that is striking the wall in the perpendicular line to the line of impact. So the remaining two equations are useless, because if I apply the equation of linear conservation of momentum for the wall in the perpendicular line, this will give me 0 times infinity is equal to 0 times infinity. And if I apply the linear conservation of momentum for the system of the particle with the wall, this will also give me 0 times infinity. So that's why the only two equations are the linear momentum conservation for the mass that is striking the wall in the perpendicular line to the line of impact, as well as the equation of coefficient of restitution. All right, guys? So let's apply them. Let's start by the linear momentum conservation of the mass, which is MB. So MB, VB1, X or Y? MB, VB1, X or Y, guys? If I want to apply this one, the linear momentum conservation of the mass in the perpendicular line to the line of impact, it's MB, VB, Y, perfect. Is equal to MB, because here the line of impact is along X, which means they have the same VBY, right? So this is the first equation. The second equation is E along X, and this means that if I start by the wall, it's 0. We can start, of course, by VB, all right? VB2, X, don't forget this X, it's very important. Do not put the module of the velocity. The magnitude of velocity is not correct, right, over VB1. So it's always the negative ratio of the velocities, X, right? Which means that VB to X now change. So it's the completely opposite from the projectile motion. Now VB to X will change while VB to Y will convert. So VB to X will be E times 10 cosine 30, of course, in the negative direction. And this is, guys, logical because it will be rebounded from the wall. While VB to Y is equal to 1.602. All right. So now I know the equation, the components of VB to Y, the component of VB2, VB2Y, and VB2X. Of course, you can find VB2 in magnitude. You can also find the angle of rebounding, all right? Because I know that 10 phi is VB2Y over VB2X. Okay. So now, guys, that I know this rebounding equation, I can now start to find the coordinates of C. Why? Because I have now a projectile motion BC. Right? So as if I have a projectile motion from this point B to the floor. All right, and I know that this is what? 3.808, and that's why, guys, I found the YB. Right, so here I'm gonna use it. All right, so that's why I found YB. Okay, now you have two options: either to take your reference at C and then YB will be positive 3.80B, or to take your reference at B and then YB will be 0 while YC will be negative. So it's up to you. The question is, in fact, to find this S. So here, guys, I have only to apply the equation of projectile. I know. So where do you want to take the reference? Do you want to take it at B or at C, guys? So the motion starts from here. I know VB1. In fact, VB1x is negative. VB1y is positive. So this is the velocity of, this is the initial velocity of this projectile motion. Right, so the curve should have this shape. Okay, so where do you want to take, guys, the reference? Do you want to take it at B or at C? At C, okay, so that you can have a positive y for B. All right. So at C, y of C is equal to 0. And at the same time, y of C is equal to minus half 9.81 c squared plus v0 y of B, which is in fact v b2y after collision, c plus y0, which is here 3.808. Now, guys, if you take B as your reference, then YB will be 0, but YC will be minus 3.808. So as if you take this value to here, all right? So it's the same. Then from this equation, I can find T. Whenever I know T, I took the reference at C. So X of C is 0. And this will be equal to VB2XT plus X0, which is S. So I can find S. Right? So it depends. What is the direction of S? S is a distance. So you have to find the absolute value of S. All right. So let's put this as X0. So whenever you find X0, which is XV, then the absolute value of X0 will be S. Right? Because this will give you a negative value since VB2X is negative. Okay, guys? All right. Okay. So I still have one last problem, which is somehow tricky, but it's funny. Okay. So in this problem, I have to include some geometry rules before solving it. So I have here in example 9, I have two billiard balls A and B that are originally in contact with one another. So they are in contact. These A and B balls are in contact. When a third ball C strikes each of them at the same time as shown. If ball C remains at rest after collision, and this is what happens, guys, in billiard, right? So C remains at rest. However, A and B will move, and due to symmetry here, they will move in the same velocity. So, guys, this is an equilateral triangle. C is pushing them with a velocity of v just before collision. Then from symmetry, guys, A will move with a velocity v prime that is equal to the velocity of B. So B also will move to a velocity of v prime, right? Because this is from symmetry. I have a ball C that is symmetrically colliding with A and B. So they will move, both of them with the same velocity. Now, since this is an equilateral triangle, and if I take this 90 degrees, this will be 30, all right? Okay. Now the question is to find the coefficient of restitution. In fact, guys, this coefficient of restitution is, the question should be more precise. What is the coefficient of restitution between C and A, or between C and B? Now, guys, here, if I take the impact between C and A, what will be the line, the plane of contact? This will be the plane of contact, right? And then this means that this will be the line of impact, right? So this will be the line of impact. I'm gonna call it X prime. And of course, this is an oblique impact, not because the line of impact is oblique, no, but because V is not along this line of impact, right? So at least one velocity is not along the line of impact, which is here V. And that's why, guys, that's why this is an oblique impact. If I want to find E for this oblique impact, E should be along what? The line of impact, which is X prime, right? So what will be E? It will be VA2, which is V prime, only because V prime is along X prime, minus VC. VC is 0. They are saying that after collision, C remains at rest, over VC before collision, which is V, the projection of V on V prime. So what is the projection of V on V prime? V cosine 30 minus the velocity of A before collision, which is 0. Right? So E is V prime over V cosine 30. I have to find also a relation between V prime and V so that I can find the value of E, which is the question here. How can I find the value of E? For sake of simplicity, guys, look what I'm going to do. I'm going to take A and B as one system, and I can do this, right? Remember the system of particles? I'm going to take A and B as one system. In this case, if C strikes the system A and B, then the line of impact will be vertical. And in this case, guys, the plane of impact will be vertical. And in this case, the line of impact will be along X, which is the direction of C. Right, guys? And in this case, I can apply the conservation of linear momentum, which states that M, they all having the same mass, V, right, plus 0 is equal to 0 plus the velocity of this system of particles. Now, what is the velocity of this system of particles? It's in fact the velocity of A on X, which is V prime cosine 30, plus the velocity of B on X, which is also V prime cosine 30, due to symmetry. And this means that MV is equal to 2M V prime cosine 30. Right, guys? If I remove M and M, then I'm going to have a relation between V prime and V, so that V prime is equal to V over 2 cosine 30. So let's substitute this in this equation. V over 2 cosine 30. So it will be V over 2 V cosine 30 squared. Then, guys, E will be 1 over 2 cosine squared 30. Right? So it's somehow tricky, but it's okay. Okay, guys? So this is for example 9. I hope this online session was useful. See you next week. And don't forget, guys, please don't forget that you have a test on chapter 15 on next Thursday, right? I don't know what time, but it will be during your online session.